Okay, hello everyone. We're just going to wait one more minute as we get a few more people logging on, but it's great to see some faces there, so welcome. Okay, perfect. We will kick off now. So first of all, welcome everyone. We really appreciate you all taking the time out to join us today. This is Utopi's very first virtual lunch and learn of 2024. So thank you again for being here. It's a really key part of our strategy for 2024 to make sure that we engage with different communities within the property and construction sectors. So yeah, our M&E session is the first of many. So just a couple of housekeeping things for today. Number one, we have a few contacts all around the world that want to watch this session, so we are recording. So if anybody is uncomfortable with being on the recording, you're more than welcome to turn your video off and just listen in the background, but just be warned, it is being recorded. Also, at the end of today's session, we will be having a bit of a Q&A or a discussion if you would like to take part. If not, we will also be sending through a Google form following the event today. So feel free to, if any questions pop up tomorrow or the next day, please make sure you send them through to us along with any thoughts and feedback, and we'll make sure someone from the Utopi team comes back to you. Final housekeeping, if you have any questions that pop up while the session is happening, please feel free to type them up and pop them in the chat box, and then we'll use that as a premise for the Q&A when we kick that off at the end. So today, the session, I'll do a really quick intro to who Utopi are for some of the new faces on the call, some very familiar faces there as well, which is great to see. And then I will hand over to Falk, who is our CTO and one of our co-founders here at Utopi. He'll take you through the session, which will be about 35 minutes. And then we'll dive straight into the Q&A and discussion. And hopefully we can all get a bit of time back at the end of the day, because we know January is a very busy time, although the longest month known to mankind is almost done. So I'll first kick off on who Utopi are for those of you who might not know us. So as the strapline says, we are a specialist ESG technology platform for multi-tenant real estate. Now, what does that mean? So we are big believers in data. Since our inception in October 2019, we have generated over 6 billion environmental data points. So we are in the game of data collection, data analysis, and data engagement tools. Always trying to empower our clients around the world to use that data as actionable insights, and not just improve their environmental footprint, but also, as everybody likes to hear, generate some pretty significant cost savings. So since our inception in 2019, we are now in over 30,000 bedrooms around the world, and we have over 45,000 active subscriptions to our Utopi platform. But one of the reasons why Utopi is slightly different to other prop tech companies is our beginnings. So Falk, the man on the call here today, was actually a digital advisor to the BTR sector through Motor Living back in 2019 and 2020. And from that knowledge of being in-house and in the sector, that's kind of how we developed the product that we have today. So we are strong believers that, you know, we solve a lot of problems for people like yourselves, but also, you know, we really believe in the market and trying to do better. So the Utopi multi-sensor, which some of you might have heard of, was innovated and released in December 2020, but the ESG solution, or what we call our MVP and what Utopi is today, was released in August 2021. So since then, we've brought on a huge amount of investment. We're active in 10 different countries, and we're also now kicking off into the US, which is very exciting. But the next slide, which I thought would be the most relevant to all of you today, is our tech stack. So Utopi is broken into these 3 core areas, and Falk will obviously take you through a significant amount of this today. But number 1 is our devices, or data acquisition, and also energy control as well. So we can collect the data through our hardware devices, but we can also ingest data from existing sources, whether that's through APIs, BMS, whatever that might be. And then our Utopi multi-sensor, which was actually created by Falk himself, and that was actually designed and manufactured in Scotland, which we're very proud of. And that generates 6 different environmental data points. So temperature, air quality, humidity, light, noise, and motion. So that's step number 1 for Utopi. Step number 2 is connectivity and getting that data onto our platform. And that's how we use these gateways here and the LoRaWAN network. And the final stage, and we call this the kind of nerve center of Utopi, is our SaaS platform. So, you know, turning that real-time granular data into actionable insights. So there we go. That's kind of a whistle-stop tour of Utopi. And I'm now very proud to hand over to Falk, who, as I say, is our CTO and one of our co-founders. Falk, take it away.
Thanks, Janelle. Appreciate that, and thank you all for joining. I hope that we'll be able to share some things that will be of interest, of relevance, and also of importance to you and your customers and the organizations that you work with going forward. And basically, one of the things that we have seen a lot of is that the topic of data acquisition when it comes to metering data in particular is often glossed over or forgotten, or is seen as an also run point of consideration, especially also when it comes to contracts that have been perhaps awarded and then you know, there's a value engineering phase that is often gone through where sometimes these things are kind of parked and left to one side. And basically what we see is that there is a disconnect between the construction of buildings on the one hand and the operation of buildings on the other. And there are different motivations and different aims and considerations. Within construction, clearly there's a requirement to deliver a compliant building to specification, and the organization leading the construction will try and do that at the lowest possible cost in the fastest possible time with the lowest possible risk. And this has all to do with the construction and less to do with the operation and the cost of operating. Whereas somebody who receives a building that has been newly built and is being handed over, the cost of the actual construction's already been sunk at that point, and operators, they care about the use, the ease of use of operating, the cost of operating, and also the ease of adoption of systems that are there. At that point, an operator will be left with what has been built effectively during the construction phase. And so there is often a discontinuity that we see between what's been built on the one hand and what's then required and wanted from an operational point going forward. I'm sure you'll all be aware of, of the letter of the law, if you like, when it comes to the building regulations. And there's a statement in there that says that automatic meter reading and data collection facilities should be installed. If you read that as a lawyer and you see the word should, you think, well, okay, that's a nice, but it's not a mandatory type thing. And, on the other hand, the TM39 guidance that is given there, talks about perhaps some of the reasons as to why this is important, and that sometimes perhaps not just actually making the facility available, but actually making the process easy is also important when it comes to the actual adoption of automated meter readings and actually gaining insights from the data that is available. This particular standard is now approaching 15 years of age, which for any standard is probably a long period of time, and in a technology field it's probably longer than an eternity, and therefore some of the things that perhaps were presupposed when that particular document was written have moved on quite a bit, especially when it comes to the cost of implementation of some of these things. And cost is one of the things that is used in that standard as a balancing tool, looking at what is cost effective to deliver a certain outcome. So the question really is, from a customer, from an operator's point of view, why do we want to measure stuff? And there's There's a lovely law, it's referred to as Pearson's law, that says when performance is measured, performance improves. And when performance is measured and reported back, the rate of improvement accelerates. And in this time of everybody's striving towards net zero carbon on the one hand, cost optimization and awareness, basically those kinds of things are a real driver, because you can't really manage what you cannot measure. And as far as our customers are concerned, the utility costs increase is a real driver, and we see that in pretty much every conversation that we have, where our customers talk about the utility costs increase being a significant aspect of their operational costs and a significant risk also. And being able to see on the one hand and to manage on the other, this significant cost item is really important. The other thing is that there are both voluntary and statutory reporting requirements for our customers, certainly, who have both financial and ESG, so environmental reporting data requirements, for example, when they look at the amount of emissions that have been generated by their operations, and in some cases also by their customer operations. And if you're familiar with the scope 1, 2, and 3 emissions, these things fall firmly into the category of things that our customers certainly want to measure in order to be able to report accurately on those things. And automated data collection, the right data collection at the right time in an easy and ideally automated fashion, is a key driver for our customers. So the question is, how do we actually achieve that? And if we look at metering in particular, the question about the types of meters becomes quite an interesting one. And you'll be aware, I'm sure, of the different interfaces that are available on meters, and what they may actually mean. Now, analog meters with a display output, they will be the cheapest ones you can find, because to be honest, they have no real practical application anymore where automated meter reading is required. And that is because really the only way to read them, if there's no other interface on them, is by somebody physically going to wherever the meter is installed, and quite often it's in inaccessible locations also. And somebody would need to physically go and look at it, physically record the information, probably on a piece of paper, and then at some point, record that somewhere on the system. So therefore, as far as we are concerned, is that analog outputs or where there's just a display is just not good enough anymore when it comes to metering, because it doesn't actually provide the capabilities that are needed, to get data out on a repeated basis in a timely fashion, and ideally also from remote or inaccessible locations. If we go to the next one, and again, most of you will have seen this, is that there are all sorts of meters that come with pulse outputs. Now, this is a typical interface that's available on utility meters. It's a single interface, so once the interface is used, then by whoever it is, that is it. Readings on pulse counters are relative, so basically they just count the increments. They don't give you, the actual absolute meter reading, only what the difference is, from the last time the pulse counter was read. You can get both optical and electrical versions of that, and they have some, like optical ones have some benefits in the sense that you can stick them onto the glass on the sensor potentially, but electrical devices typically need permission from the meter provider, to actually read the electrical interface. And with that, you have a one-to-one ratio between the reading device on the one hand and the meter. And there's physical cabling needed, to actually connect a pulse counter to a reading device in some shape or form. The benefit really is that it's simple, it's generic. you know, and then any reading of that, you know, is something that is done typically on a software platform that gives you that. But to us, certainly, with some of the things that we do, especially in a retrofit scenario, it means that we come across situations like this, where somebody's already put their beach towel on the sun lounger, so to speak, and you have your pulse output already in operation somewhere by somebody, you know, and it's not actually available to you. And so this is something that we've certainly seen on a number of occasions, where you intend to actually, you know, go and get a meter reading in an automatic fashion on a pulse interface, but it's not available because it's already being used. Again, many of you will be familiar with Modbus as a data protocol, and with that you have, you know, integration requirements, because each device says each device that you can get will come with different registers that are in need of reading, and quite often the encoding is different as well from device to device. Again, there's physical cabling required. You have a master-slave configuration, which means they only respond actually when they've been asked for information. And when it comes to troubleshooting and snagging, because you have a wired data connection, you know, that can be difficult when you have a daisy chain of a number of devices. And Modbus allows you to read up to 30 devices with one Modbus master, if you like. But you know, some positives are that cabling for Modbus can connect different types of devices, different types of meters. You can get some additional data, so it's not just the absolute reading that you may get, but in the case of an electricity meter, you may get things like voltage, so supply voltages, power factor, and other metrics, which actually can help, you know, from a remote diagnostics and troubleshooting point of view. And you get absolute values, so you get the absolute meter readings, and Modbus devices are often used for integration with BMSs. If you look at wired M-Bus, you know, again, there are integration requirements, physical cabling, again, the master-slave type setup. And because you can have a greater data cabling size, on the one hand, that's really good, and the topology of the data cabling is quite flexible. On the other hand, it can be really troublesome when it comes to troubleshooting. You know, being able to find where like a cabling fault lies, if a nail or a screw's been put through a cable, or a cable has been severed somewhere behind the finished wall or so, it's really difficult to actually find that and then actually rectify it as well. So, and again, with that, you know, some of the other benefits that are mentioned there are similar to the Modbus ones. And this is certainly in the UK, from what we've seen, like one of the de facto standards when it comes to metering, and how metadata is gathered, certainly in a residential, like multifamily living type setup. Modbus is quite often used on distribution panels. So, there's another alternative, and it's a wireless M-Bus solution, which requires dedicated receivers, so dedicated, you know, read infrastructure effectively. And again, you know, some of the drawbacks are similar, but you overcome some of the challenges by having a wireless communication, and the ratio of meters to read devices is going up again. But to us, one of the challenges, or one of the drawbacks really, is that it's a dedicated solution only for meter reading. It's not a solution that you would use for other purposes. And this is where our friend comes in, really, in this respect, and that is LoRaWAN. LoRaWAN is a low power wireless technology that we use as a strategic wireless infrastructure for IoT services within buildings. And while there is an integration requirement because each device has a different payload, or each device type has a different payload, there aren't really any practical limits on the number of devices. Gateways, like I said, can be used for other applications, and you can get a whole variety of additional data. And this is really interesting also, because this technology doesn't work in the master-slave type setup. Devices can actually report out of sequence, and water meters are a great example for that, where water meters are available that have leak and burst detection alarms that they can send, out of their standard reporting frequency, to actually alert, the operator that there is, a problem that needs to be attended to. When it comes to installation, we believe also it's the least labor-intensive installation because there is no data cabling required, and again, no troubleshooting from a cabling point of view. And the troubleshooting when it comes to the connectivity for these devices is something that we do through our platform by being able to share, for example, signal strength of received signals, and also seeing where potential problems are. And we address that typically by making sure that the network, as in the wireless infrastructure, is designed carefully and to a high standard, so that network connectivity issues are rarely an issue for us. In fact, through careful planning, we overcome this as an issue pretty much without exception. So, and with that really, and having reviewed these things, the question really is one of strategic versus tactical design, and when it comes to some of the other things, and again, I'll speak about multifamily living perhaps on the one hand. If you take student accommodation, for example, where strategic design, should include, and it's the same for other areas also, circuit design that actually considers metering requirements. We have seen cluster apartments where you have multiple bedrooms, for example, served by a single consumer unit, and then circuits for electric panel heaters, for sockets, and for lighting, spanning several, and quite often not even the same residential rooms, so that you're not able from a metering point of view to actually outline and define what an individual unit is actually measuring. Consumer units with space in them to actually, accommodate meters and metering, renewable and on-site generation, and the consideration for that as part of the metering process. And we have worked with clients who have actually used the circuit and meter design and meter strategy as an integral part of them testing various scenarios with regards to air source heat pumps, other HVAC type systems, water heaters, electric water heaters, for example, to actually understand how these various systems actually work in a real life environment, in combination with each other or potentially as alternatives. And the insights from these kinds of things actually help then define the future designs potentially as well. It's the same with water pipes and where they run and how they are actually implemented, especially when you have the opportunity from a new design point of view to consider metering of those resources as well. And that really, with all of this, rather than just having a device that has the capability to provide you with a meter output, that you're able to actually have a platform to measure and analyze that consumption. And that's in stark contrast, to the tactical design, which is value engineering potentially for cost optimization only, complying with the letter of the law, the minimum requirements in Part L of the building regulations, looking at the capability of a device rather than the overall solution. So saying that, well, a meter is capable of external communications because it has a pulse output. But if you have 200 meters that you want to read, each one of them has a pulse output, and that's not provided as part of a solution. It is only really half a solution, complying again with the letter of the law. And then sharing of consumer units, circuit spanning, different areas we've already said. Putting everything into the BMS is an interesting one. I'm sure many of you have come across the fact that if you use the BMS as a repository effectively for data, it may be difficult to actually get the data out because BMS interfaces are often restricted. We've seen one of the most ridiculous ones I've seen was actually a BMS control panel being at about waist height in a busy corridor in an office space, and nobody had access to it, and didn't know what to do with it. So the capability was there, but the data was in the wrong place and nobody was able to actually get any data out. And it wasn't at that point, that one wasn't connected in any other shape or form to actually be able to get the data out. And then also limiting metering, is a tactical thing, where the question, and the balance of how many meters, for what kind of an application is one that shouldn't just be answered from a cost point of view, but also from a practicality point of view. And again, through some of the things that we've done, measuring very much at granular levels, we've been able to see, some quite unexpected things, unexpected high usage, unexpected under usage. And then when you add context to that data, when you know what's actually being measured, it can actually help, drive operational excellence and efficiency. Just wanted to share with you a couple of horror stories, perhaps, as to what we've seen in real life. So the picture on the left is just an unterminated cable, and the wrong type of cable. This one's an Ethernet cable that was going to be used for wired M-bus rather than Belden cables. Crazy connections, as you can see there, poorly terminated devices, and the image on the right is part of a distribution board at a customer site where this was a site that had been operational for well over 15 years, and their meters all looked like this. They all showed zeros. So, and what we actually found out when we looked into it, because we were going to get the remote data out of those devices, that basically the current transformers that actually do the current reading on the circuits, they were all installed back to front. So, and the meter was not able to show export, only import, and with that, literally every meter for the last 15 years only ever showed a zero. So these are just some of the things, that we've seen. We've seen wrong data sets where the meter serial numbers and the device credentials weren't provided correctly. BMS is not configured, not connected, different meter types where one type was compliant and communicating and another one wasn't, and so on. So these are the kinds of things in real life that we've seen. And clearly, if you want to get data out, when it comes to the actual electrical safety in this case, perhaps there wasn't an issue, but when it comes to the data quality and the intent for what these services have been installed, that it clearly doesn't fulfill the requirements that customers have in that instance. So coming back to our solution, what we offer is devices, network, data platform, an end-to-end solution, and through that, real-time, granular, and contextualized data and the analytics that come from the back of that. Okay, and I've given some examples of devices, and from an M&E point of view, really, what we offer, and this is just as important, I think. We offer a meter installation that is quicker, less risky, it's easier to troubleshoot, more capable, and cost-effective to install than other metering solutions. And basically, what I'm showing here in the top right corner is a heat map where this is a building which was in the process of being commissioned, and we could show not only the meter reading for every single one of those spaces, but we could also show which devices were live, which devices had stopped communicating. And basically the reason behind that was that somebody just in a building that hadn't been handed over had switched off some of the consumer units and the electrical supply. And here you can even see that, you know, this particular space, you know, had an electricity reading. The last reading was about 12 hours ago, which means we know that this device did communicate at one point. There's further diagnostic information sitting behind that can actually help with the troubleshooting, so that rather than having to go to every single device and actually, you know, reading the information or having to look in a consumer unit, in this instance, we can basically show all this information on the main platform right away and at once. And you know, for the M&E contractor, the devices that we provide come pre-configured. We have an installer app that actually helps scan a device and assign it to a particular installation location. And we provide remote installation support for that as well. And the gateway network, as far as the radio backhaul is concerned, is underwritten by us also to make sure that that is reliable and working the way that's supposed to. And really, for the customer, what we offer is an end-to-end solution that basically gives them the metering for their own purposes and analytics, potentially for billing purposes. And some of our customers use our data for billing purposes for their end customers, and also to give customers insights and the tools to actually manage their operational excellence, throughout the lifetime, of their asset. So just really in summary, some of the key takeaways, please do consider meters in the service design, consider and build, the automated data collection, again, in line with what the regulations recommend, strongly recommend perhaps. Metering, we believe, shouldn't necessarily be part of the BMS scope, because the BMS is just a black hole in that case, often where the data goes, never comes out again. And the meter device data really is critical, also to make sure that the correct devices are assigned to the right spaces. And I hope that, as we claimed when we invited you, that this also gives an indication that better data does not necessarily mean more cost. We truly believe, and we've seen this with some of our customers who used to deploy wired M-bus meters and who are now deploying the LoRaWAN-based solutions that we've been talking about, that they are seeing real benefits, coming out of this, and also that the installers and the contractors that deploy the hardware that this data comes from see real benefits for their deployment by reducing risk, reducing cost, and increasing speed of installation and deployment. And that's it, really. And now we have the opportunity to install and answer any questions that you may have. So I'm happy to basically do that, and I will stop sharing my screen and hopefully can see some of you in some more detail if you have your video on. And
thank you so much for that, Volk. We actually have our first question through in the chat, so we'll kick off with that one. It's from Francis. She said, how easy is it to install and commission a LoRaWAN-based metering solution when compared to wired M-bus? Okay, so as far as the physical installation of the device is concerned, depending on what kind of meter it is, let's take a water meter. Water meter might be an interesting
solution. So you have your inline water meter and you install that. That physical installation is no different from from a wired device to a wireless device. However, when it comes to the data collection element, with the LoRaWAN meter, all you need to do is scan a QR code with an app, assign that particular device to the space where it's actually been installed, which has been preset on the platform. And with that, you have done the data installation. If you use, let's just say wired M-bus, for example, you need to have a wired M-bus cable that goes from the device through whatever intermediary devices you may have to a data logger, which is likely to sit in a riser somewhere, which is then required to have an Ethernet connection out, and so on. And basically, you need to make sure that the whole daisy chain of devices on a wired M-bus is complete, doesn't have any breaks in it, doesn't have any short circuits in it, and so on. Each device will need to be configured with a wired M-bus address, and the data logger needs to be configured to effectively deal with that information, and then the data logger needs to send that data out to the data collection point that you want to deal with. So I hope that kind of shows the difference. And if you just look at the physical installation alone, the total omission of having to have the data cabling connection and the troubleshooting that goes with it already wins hands down as far as the installation is concerned. And installing the data cabling in that kind of a scenario is a non-trivial task that's often done by somebody else, other than the plumber, if we talk about a water meter, who would be doing that. So it's different trades basically, working on the same solution as well.
Great. We've got another one. So from David, the Utopi solution is clearly a no-brainer for applications such as student accommodation and build to rent. But what about projects such as offices and even industrial warehouses?
Okay. Good question. We focus our efforts really on managed residential, but we do have deployments also in commercial offices, and typically their metering again is something that often has been an afterthought when it comes to metering individual units, or perhaps certain services within individual units. But again, deploying gateways and installing devices, is just as easy in that kind of an environment as it is in managed residential. And because it's so easy to retrofit, if you try to retrofit automated data collection using wired cabling, that's a non-trivial task, because you end up pulling cables, and again, if there are any problems, quality problems when it comes to the physical cabling install, it can be difficult to rectify those.
Great. Okay, next question we've got is from Gillian. How effective is LoRaWAN metering solutions when thinking about the future proofing of buildings, e.g. might be moving from a multifamily rental to a private for sale model?
Okay, now that's a really interesting question, and I would go so far as to say that when it comes to the utility distribution within a building when it's built, if you want to hedge basically the options there, that you may want to consider actually putting like a DNO electricity distribution into the building, which means that the network operator, the utility company, effectively provides the distribution infrastructure into the building, right into the apartments that you are servicing. And we've seen that with some of our customers who have done exactly that, or customers who have bought parts or whole single family housing estates where the electricity distribution is already a standard utility model. But what they still want is that data in order to help them manage their ESG reporting requirements, and also, while properties are being rented out, get some of the benefits like I hinted at for the water meters, being able to see, if there are leaks or bursts in a property, which otherwise they would have no access to, even with a utility meter provider.
Great. Okay. Thank you, Falk. Last question in the chat for now is from Adam. He says, what do you need to do in terms of troubleshooting on LoRaWAN, and how does that compare with wired solutions? So
troubleshooting with the LoRaWAN solution, basically, the way we do it is we deploy network and we deploy gateways, throughout a building in a fashion that we design to a high quality of radio signal within the building. And typically, because we provide layered services, so in the same building you may have the multi-sensor that we talked about at the beginning, you may have 2 or 3 different meter types, and potentially other devices also. Through that process, we can actually build a map of how good a radio signal is within a certain area. And, we can see where the signal is, we talk about like 100% or 80% or 60% or so. And we can see with that, from the devices that we deploy, effectively heat map of how good the signal is in a given space. And if you have a device that isn't connected, despite the fact that the signal strength is good, that typically then points to a problem with a particular device. But the beauty is that because on the platform, like I showed earlier on, with the electricity meters, because you can see on the platform which devices are fine and which are communicating, and you actually do get the comms data out of them, it is then easy to actually pinpoint which space, which apartment, actually has the problem, and where the device is, and you can then send the engineer that is there to rectify that problem directly to those spaces that are problematic, instead of having to go to every single space, and having a look at it from that point of view. And then, with electricity meters, we often see things like the mains power being switched off, for example, or with a heat meter, that an HIU, has the power switched off, and if the heat meter is powered by the HIU, then clearly it's not communicating for that particular reason. But the data will actually give you that indication. You'll also be able to see 0 meter reads very quickly. So even things where the device is communicating, the platform will actually help you identify where there are, potential further problems.
Great. Okay, next question from David. Do Utopi have standard specification clauses for their products and metering solutions, which could be considered for inclusion into M&E specifications?
Yeah, thanks for that. We do have documentation that some M&E contractors are using, or some clients are using, to basically put into their specifications in order to make sure that they will then benefit, from the application and the platform on the one hand, and hopefully, a cost benefit also as far as the installation and device costs are concerned. So yes, is the answer.
Great. Okay, so that comes to the end of the questions in the chat. Just before we finish up, we've made really good time today. Are there any other questions that anybody would like to ask? Feel free to use the raise your hand feature here. If not, we just want to say thank you again for taking the time out today to spend with us. I'm sure you all got some great insights from Falk. He's Yeah, got a great reputation for a reason. So just to reiterate, as I said at the beginning, we will be sending out a Google form following this today. So if any other questions come up, if you've got any other thoughts or feedback, or even any insights from your own experiences that you think would help us at Utopi, please feel free to send that through. You've also all got my email. I'm Chanel Turner-Ross, our head of marketing. So feel free to reach out to me directly as well at any time. But thank you very much, Folk. That was absolutely brilliant. And thank you again to all of you for being here today. Also, I'm sure you all have connections in the architecture world. Our next virtual lunch and learn will be for architects. So please pass on, who Utopi are, and we hope that we work with you all in the future. So thank you very much and enjoy the rest of your day.
Thank you. Thanks. Bye-bye.